Hello, and welcome back to the Chris and Emma Show. I'm Emma Advanced, here with my ever-so-charming co-host.
The one and only, Chris the Plant-Based, and thank you everyone for tuning in. If you're new to our little corner of the podcast world, do us a favor and hit that subscribe button. You won't want to miss what we're cooking up next.
Absolutely. And a massive, heartfelt thank you to everyone supporting us and making this show possible. Your support truly means the world.
It genuinely does. Right, so today, Emma, we're sinking our teeth into something I find pretty fascinating. The science behind flavor, specifically in vegan food, and how it's all tangled up with our health as well.
Precisely. And let me tell you, it's quite the mouthful, in the best possible way.
It really is. Our mission today, for you folks listening, is to give you the shortcut. We want to pretty much demolish any lingering, dreary notions that vegan food is somehow bland. We're going to reveal the actual, undeniable science that explains why plant-based dishes can be so incredibly bursting with flavor, and how that very flavor is often a direct indicator of its health benefits.
Exactly. Think of it as lifting the lid on the magic pot of vegan deliciousness. And the very first crucial point is that flavour isn't just about taste. Oh no, it's a far grander affair.
Okay, Emma, let's dissect that, shall we? Because typically, when we think of taste, it's the usual suspects, isn't it? You know, sweet, sour, salty, bitter, umami. The end, right?
That's the common misconception, isn't it? But in reality, flavour is a magnificent multisensory extravaganza. Your brilliant brain is constantly juggling and integrating signals not just from taste, what happens on your tongue, but also from smell, texture, temperature, and even the cheeky little sounds your food makes as you're enjoying it. Plus, those other chemical sensations we'll get to. It's a whole, glorious package deal.
Okay. Put a pin in the sound and chemical sensations for a moment. We'll definitely circle back to those. But let's start with the absolute fundamentals. The chemical senses, taste and smell.
Right, the gustation side of things, that's just the fancy scientific term for the sense of taste. We're all familiar with the 5 basic tastes, aren't we? Sweet, like the natural sugars dancing in fruit. Sour from acids, think a zesty lemon. Salty, well, that's rather obvious, isn't it? Bitter, consider the wonderful glucosinolates. Those are specific compounds in cruciferous veg like broccoli or kale that give them their characteristic bite. And then, the magnificent umami, that deep, savoury, almost meaty satisfaction you get from glutamate, an amino acid found in things like ripe tomatoes or earthy mushrooms.
And the science behind it is pretty cool. There are specific receptors, like tiny docking stations on our cells, for these tastes, like TAS2R14 and TAS2R38 for bitter, or the TAS1R2 and TAS1R3 for sweet stuff. Interesting biological machinery just for taste, right?
Precisely. And TAS1R1 plus TAS1R3 for umami. It's quite astonishing, isn't it? The sheer biological engineering dedicated solely to detecting these basic tastes.
But you said smell is where the real party is at, where most of the complexity resides. Olfaction, as the clever folks call it, the sense of smell.
Oh, without a shadow of a doubt. Smell contributes the vast majority of the exquisite nuances we perceive as flavour. And there's a rather crucial distinction in how we smell things. There's the straightforward nasal olfaction, that's just sniffing through your nose like catching the glorious scent of a blooming flower, or your morning coffee brewing. The initial greeting, if you will.
Okay, gotcha. So like the first impression.
Exactly. But then, there's the star of the show when it comes to eating, retronasal olfaction. This magic happens while you're actually consuming the food. As you chew and swallow air laden with aroma molecules, those tiny volatile chemical compounds that carry scent is gently pushed up from the back of your throat into your nasal cavity.
So that's the flavor experience you get when something is truly in your mouth being worked on. That makes sense.
Precisely. It's the absolute key to that rich, immersive, in-mouth experience. And it gets even more delightfully complex. I came across the term perireceptor events.
Perireceptor events? What on earth is that? Sounds rather, dramatic.
It does, doesn't it? It simply means things that occur before the aroma molecule even reaches its receptor, its docking station. For instance, proteins in your saliva or nasal mucus can actually bind to aroma molecules, or enzymes, biological catalysts, can subtly alter them.
So, wait, so my own spit can change the flavor? That's a bit weird, but cool.
In rather subtle yet significant ways, yes. It essentially modulates or adjusts how those volatile compounds interact with your smell receptors. Then your magnificent brain, particularly areas like the orbitofrontal cortex, a part of the brain just behind the eyes involved in decision-making and processing sensory information, takes all these disparate signals, the taste, the retronasal smell, and seamlessly weaves them together into that unified, glorious perception we call flavor.
Okay, so a really practical tip we can take from this for everybody listening would be that techniques which help release those aromas in the mouth are absolutely vital, like chopping fresh herbs, basically.
Absolutely crucial. Simple things like finely chopping fresh herbs right before adding them, cooking things just enough to release those lovely volatiles, the easily evaporated aroma compounds, warming food, and even using fats because they're brilliant at dissolving and carrying certain aroma compounds. It all works together to enhance that retronasal smell and truly boost the flavor experience.
Absolutely makes sense. All right, moving beyond taste and smell, we really need to stress the importance of texture and mouthfeel.
Hugely, monumentally important. Texture is about the physical properties you feel. Is it smooth, delightfully crunchy, satisfyingly chewy? Mouthfeel is a broader concept, encompassing things like temperature and those chemical sensations. Chemisthesis, which we'll get to, we touched upon earlier.
And texture isn't just about the sheer enjoyment, is it? It actually directly affects how flavor compounds are released.
It absolutely does. Just think about it. A velvety, creamy soup coats your mouth in a completely different manner than a crisp, refreshing salad. That difference profoundly impacts how and when taste and aroma compounds reach your receptors.
And this feels extra important in vegan cooking, doesn't it? To consciously replicate or provide those satisfying textures we might traditionally associate with, animal products. It's a key part of making vegan food appealing to us and, well, to everybody, right?
Exactly. We need to be intentional about building texture using the incredible array of plant ingredients available to us. Starches providing body, pectin, a type of fiber found in fruits, creating lovely gels, plant proteins offering that satisfying chewiness, fats contributing richness and smoothness.
Excellent. Yeah. So techniques like blending cashews or seeds for creaminess, or, roasting vegetables until they're beautifully crispy, using grains like farro or barley for a delightful chew. It's all an integral part of crafting the overall flavor experience. It's not just about taste.
It truly is, which, rather neatly, brings us to that other fascinating sensation, chemisthesis. It literally means the feeling of chemicals.
Right, okay, yeah, you mentioned this earlier. Not taste, not smell, but a physical sensation like heat, like when you eat a really spicy pepper, right?
Precisely. It's those sensations like the fiery burn from a chili, capsaicin is the active compound, the cool, refreshing blast from mint, menthol is the key player there, the lively tingle from carbonation, the sharp pungency of mustard. These aren't detected by taste or smell receptors, but by the somatosensory system, the part of the nervous system dealing with touch, temperature, pain and pressure, mainly via trigeminal nerve endings in your mouth and nose. Think of it as the sense of touch inside your face.
And this is where those TRP channels you mentioned before come into play. I remember you talking about those just a little bit ago.
Indeed. These transient receptor potential channels are like little sensors, ion channels in our nerve cells that respond to specific chemicals and temperatures. TRPV1, for instance, reacts to capsaicin in chili and actual heat. TRPM8 responds to menthol in mint and cold temperatures. TRPA1 gets triggered by compounds found in garlic, mustard, wasabi, and even the carbon dioxide in fizzy drinks.
Oh, wow. Okay, so that spicy kick from a chili is literally activating a heat sensor in your mouth. That is pretty wild. My mouth is like a science experiment, yeah?
Pretty much. And these sensations don't exist in a vacuum. They absolutely interact with taste and smell, adding yet another magnificent layer of complexity. Just think about how the heat of a chili fundamentally alters how you perceive the other flavors in a dish.
And so many vegan staples are absolutely packed with these compounds. Spices, herbs, garlic, onions, mustard greens. It's like a flavor goldmine.
Totally. It's a remarkably powerful tool in the vegan kitchen for adding excitement, depth, and intrigue.
All right, Miss Advanced. So we've got taste, smell, texture, chemesthesis, but our minds play a really significant role too, don't they?
A colossal role. Flavor perception isn't simply a case of bottom-up sensory input. It's heavily influenced by top-down factors like memory, emotion, culture, and even our expectations.
The classic comfort food effect, right? Something tastes inherently better if it conjures up a warm, positive memory, doesn't it? Like your grandma's cooking, maybe.
Precisely. And smell, in particular, is incredibly deeply linked to memory and emotion. The olfactory bulb, the smell processing center in the brain, has direct connections to the amygdala, involved in processing emotions, and the hippocampus, crucial for memory formation, the brain's centers for emotion and memory. Odors can trigger incredibly vivid recollections and feelings.
And your mood can actually affect how things taste, from what I understand. Is that right?
Subtly, yes. And culture, of course, shapes our preferences massively. What's considered utterly delicious varies dramatically across the globe.
You know, that makes perfect sense. Even simple expectations, like if a dish looks visually appealing or has a, fancy name, you might genuinely perceive it as something that's going to taste better, but it's all in your head, yeah?
Definitely. And that brings up a truly excellent point here, particularly for people transitioning to veganism. Using familiar plant-based flavors from their own cultural background can be incredibly helpful. It taps into those positive memories and emotions, making the transition feel much more satisfying and less daunting.
Awesome. So that's some really practical advice there. Start with what you know. Now, let's circle back to that curveball that you threw earlier. Sound. The seemingly forgotten flavor sense. How on earth, by the way, does sound affect flavor? Because to me, that just seems a little bit odd.
It's primarily linked to texture perception, Chris. The sounds food makes while you're eating, the satisfying snap of a fresh carrot, the delightful crunch of a crisp, they reinforce the textural sensations happening in your mouth.
Right. I got you there. So I can almost hear the crunch now. It definitely adds something, doesn't it? Like popcorn, for example.
Studies have actually shown that higher frequencies are linked to perceived crispness, while lower frequencies relate to crunchiness. You can even, rather amusingly, trick people's perception of crispness by altering the chewing sounds they hear through headphones.
Wait, okay, hold on, no way. That is pretty wild. So, if I eat a soft apple, but I hear a loud crunch, then my brain thinks that it's crispy? That's crazy.
Pretty much. And it's not just the food itself. External sounds, background noise, even the music playing can potentially modulate or influence flavor perception, perhaps by affecting our attention or mood.
So, actively trying to create those satisfying sounds in vegan cooking, getting vegetables truly crisp, adding crunchy toppings like toasted nuts or seeds, actually enhances the flavor experience through the sense of sound, not necessarily through your taste buds. That is a pretty cool trick.
It absolutely does. It adds yet another fascinating sensory dimension to the meal.
All right, Em, so this is actually blowing my mind a little bit here. So, to create all these complex layers of flavor, we need a well-stocked vegan pantry, right? Variety seems to be the absolute key here.
Absolutely essential. A truly well-stocked vegan pantry thrives on the incredible, breathtaking diversity of plants. Fruits for sweetness, sourness, and juiciness. Vegetables offering everything from earthy depths to delightful bitterness, sweetness, and umami. plus textures galore.
Yeah, of course. And legumes for earthiness and body, grains for subtle flavors and textures, and don't forget about those nuts and seeds.
For glorious richness and healthy fats, herbs for aromatic complexity, spices for concentrated bursts of aroma and heat, fermented foods for that wonderful tang of sourness and umami, seaweed for those intriguing briny notes.
Right. And other clever enhancers like nutritional yeast for that cheesy hit, or soy sauce for, of course, deep umami. It's not just a palette, it's a whole vibrant spectrum to work with. It's like an artist's paint set, basically, right?
And that variety isn't just a boon for flavour, Chris. It's absolutely crucial for nutrition and for nurturing a diverse, happy gut microbiome too. That's the community of trillions of microbes living in our digestive tract.
That's right. We just learned about them, about 2 episodes ago?
We sure did, Chris. It's amazing how much the gut microbiome influences our overall health.
Great point, Emma. Now let's get down to the nitty-gritty. The chemistry of some common ingredients that we should definitely highlight. Lemon, for example.
Right. Taste-wise, it's that bright, sharp sourness from citric acid, balanced by a little background sweetness from fructose and glucose. But the real magic, the aroma, is that incredibly bright punch from volatile compounds like limonene and citral. These are specific molecules responsible for that characteristic citrusy scent.
And those little things are really delicate, aren't they? You have to be careful with them.
Very much so. They degrade quite easily with heat and time, which is precisely why fresh lemon zest is so much more intensely aromatic than, say, lemon juice that's been boiled for ages.
Okay, I gotcha. That makes sense. So how about tomatoes? They seem deceptively simple, but they're pretty complex, aren't they? Like a secret agent of flavor.
Taste-wise, you get that lovely balance of sweet sugars, sour citric and malic acids, and that wonderful umami from L-glutamate. And the aroma. Over 400 volatile compounds have been identified. It's a complex symphony. Key ones give those fresh, green notes when raw, like hexanol, while others, like beta-iron-1, contribute floral hints. Many of these compounds come from the breakdown of carotenoids, plant pigments like the red in tomatoes, and fatty acids. And cooking? That transforms them completely. Less green, more cooked, sometimes even developing intriguing sulfur notes.
Fascinating. And mushrooms, the undisputed kings of umami in the plant world.
Indeed. That intense umami comes not just from L-glutamate, but also from these rather clever 5' ribonucleotides like GMP guanosine monophosphate. They work synergistically, meaning they boost each other. The combination is far, far more savoury than either compound alone. Plus, you get a touch of sweetness from mannitol, a type of sugar alcohol.
Yeah, and that utterly distinctive mushroom smell, like the forest floor, right?
That's mainly down to compounds like 1,0-CTEN-3-OL, often affectionately called mushroom alcohol. It's generated by enzymes when the mushroom tissue is damaged, like when you slice into it.
Ah, okay. Now, let's talk about garlic. We know it's wonderfully pungent. It's known as the stinky rose.
But the true magic, the transformation, happens when you break it down. Intact, a clove is relatively mild. But crushing or chopping releases an enzyme called alliinase, which converts a compound called alliin into allicin. That's the source of that sharp, fresh pungency we know and love.
But allicin isn't particularly stable, is it? It doesn't stick around long.
Nope. It quickly breaks down into other sulfur compounds like diallyl disulfide and diallyl trisulfide. And heating it, that transforms it completely. It becomes much less pungent, significantly sweeter, developing those lovely roasted flavours from different sulfides and even pyrazines, compounds often associated with roasted or toasted scents. Aged black garlic is a whole different beast again, isn't it?
Okay, so let's talk about cruciferous vegetables, the ones that people love to hate. You got broccoli, kale, cabbage. Now these are sometimes bitter and sometimes pungent as well.
The bitterness comes from those glucosinolates we mentioned earlier. And rather interestingly, how bitter they taste can actually vary genetically. It depends on your TAS2R38 gene. And when you damage them, an enzyme called myrosinase breaks down those glucosinolates into isothiocyanates, or ITCs, like the famous sulforaphane. These are what give the pungency, and sometimes those characteristic sulfur aromas. Overcooking, sadly, can intensify the less pleasant sulfur notes.
But roasting helps, doesn't it? I mean, that's my go-to for broccoli.
Roasting is a game changer. It can reduce bitterness and develop sweetness through caramelization, the browning of sugars. It completely changes the flavor profile for the better.
All right, good to know. Now lastly, oats, the breakfast champion. Seemingly plain, but clearly not. What do you got, Em?
Mildly nutty and sweet when raw. But processing and cooking, especially toasting, really brings out those complex Maillard reaction flavors. That's the chemical reaction between amino acids and reducing sugars that gives brown food its distinctive flavor, resulting in more developed roasted notes. And the texture.
The beta-glucan, a type of soluble fiber, gives oatmeal its wonderful thickness and oat milk its creamy mouthfeel. It's the secret ingredient.
Exactly. That soluble fiber is absolutely key for mouthfeel. Oats also contain unique antioxidants called avananthramides, but you do need to inactivate certain enzymes during processing to prevent rancidity from lipid oxidation. Basically, the fat's going off.
Very interesting. There is genuinely so much science packed into even a simple bowl of oatmeal. It's amazing seeing the chemistry behind it all, isn't it?
It truly does tie it all together beautifully. And then, the connection to health. This is where it becomes even more compelling, wouldn't you agree? Flavor and function.
Absolutely, because these flavor compounds aren't just sitting there tasting nice, they're often actively doing wonderful things in our bodies, too. It's a win-win.
And limonene, that lovely citrus aroma, has shown promising anti-cancer potential in preclinical studies. That means studies done in labs or on animals before human trials, plus antioxidant and anti-inflammatory activity.
What about glutamate from tomatoes and mushrooms? Besides the umami, what's it doing?
Besides contributing to that glorious umami taste, it's an essential amino acid, acts as a neurotransmitter, a chemical messenger in the brain, and contributes to satiety, helping you feel full and satisfied.
Alright, and the other tomato compounds, like lycopene and beta-carotene, the colorful ones.
Powerful antioxidants linked to a reduced risk of cardiovascular disease, heart and blood vessel problems, and certain cancers. Beta-carotene is also crucial for converting to vitamin A.
Okay, so we touched on garlic and allicin a little bit earlier. So garlic, allicin, and its friends are actually known for, making your breath smell pretty pungent. But what about health stuff?
Their impressive antimicrobial effects, fighting off microbes like bacteria, cardiovascular benefits, antioxidant and anti-inflammatory actions, and potential anti-cancer activity in lab settings. They interact with enzymes and signaling pathways in fascinating ways.
And the ITCs from cruciferous veg like sulforaphane, I hear a lot about that one.
Again, widely studied for their potential anti-cancer effects, often linked to inducing detoxification enzymes, specifically phase 2 enzymes, which help your body process and remove harmful substances, and promoting programmed cell death, also called apoptosis, in cancer cells. Rather clever little molecules.
Okay, so let's shift to beta-glucan from oats. We know the texture effect, but what about the health benefits? Oats are known for lowering cholesterol, right?
Famous, absolutely famous, for helping to lower cholesterol by forming a viscous gel in the gut. It also assists with blood sugar control and acts as a prebiotic, feeding those beneficial gut bacteria we love so much.
And those oat avananthramides, the fancy name ones.
They boast antioxidant, anti-inflammatory, and anti-allergenic properties, essentially helping to protect against the hardening of arteries.
And even capsaicin from chilies. Let's go beyond the heat here. It's not just pain, is it?
Capsaicin from chilies isn't just about the heat. It's used topically for pain relief via the TRPV1 channel, and research is actively exploring its potential metabolic benefits. And let's not forget dietary nucleotides, the building blocks of DNA and RNA from mushrooms or nutritional yeast, important for immune function and gut repair. And polyphenols, a vast, incredible class of compounds found everywhere in plants, renowned for their antioxidant and anti-inflammatory effects, supporting heart and brain health, and modulating the gut microbiota, meaning they influence the balance of our gut bugs.
And then there's just good old general dietary fiber, which is absolutely crucial for gut health, producing those beneficial short-chain fatty acids when fermented by our gut bacteria. The list goes on and on. It's amazing how much is packed into plants, isn't it?
It truly is astounding. But it's important to clarify something here, which we should highlight. It's a subtle point, but key.
Yes, that the health benefit comes from the chemical compound itself, not necessarily the sensation it produces. The taste is a clue, but the molecule does the work.
Right, exactly. The taste or smell might be the signal that tells you the compound is present, but the biological effect happens because of how that specific molecule interacts with your cells or systems. The sensation is the messenger, the compound is the actor.
That's a really crucial distinction to make. Okay, so armed with all this rather brilliant knowledge here, how can people listening actively cultivate their vegan palate? How do they become flavor masters, Emma?
I think the best place to start is with the most exciting part, exploration. Be adventurous, Chris. Try different fruits, vegetables, ancient grains, legumes you've never cooked with before. Dive into the incredible variety of nuts, seeds, herbs and spices available. Don't be afraid.
And don't be shy of fermented foods or sea vegetables either. They add such unique dimensions. Literally go wild.
Exactly. Take it gradually, perhaps one new ingredient a week. Aim for diversity. It's not just good for your taste buds, it's fantastic for your gut microbes too.
Alright, so we've explored the ingredients. Let's talk about techniques, cooking specifically. We don't want to just boil everything, right?
Yes. Understand how cooking utterly transforms flavour. Roasting and grilling develop incredible depth through those magical Maillard reactions and caramelization. Fermenting creates complex sour and umami notes, plus those lovely probiotics.
Yeah, definitely. Sautéing also builds wonderful base flavors. Pickling adds a vibrant brightness to different vegetables. Slow cooking melds everything together beautifully.
Even simple techniques like steaming for consistent texture, drying for concentrated flavours, or keeping things raw for peak freshness. Each technique unlocks different potential within plant ingredients.
And look globally for inspiration. The world is your kitchen.
Definitely. So many cuisines have absolutely incredible plant-based traditions that predate modern veganism. Indian food with its masterful, complex spice use. Just be mindful of ghee. Thai cuisine, brilliantly balancing all the tastes. Check for fish sauce. Ethiopian stews served on injera are often naturally vegan and utterly delicious.
Yeah, then you have Mediterranean and Middle Eastern food, things like hummus, falafel, loads of fresh vegetables and legumes. You have Vietnamese cuisine with its abundance of fresh herbs and perfectly balanced flavors. Again, sometimes you got to check for fish sauce. Traditional Mexican cooking relies heavily on corn, beans, squash, and chili. You just got to check for lard.
And Japanese Shojin Ryori, Buddhist temple cuisine, is fully vegan, seasonal, subtle, and incredibly refined. Even Caribbean ital food. Learn the philosophy, not just the recipes. Wonderful suggestions, Chris.
And finally, let's get to the art of pairing flavors. Making things just sing together. It's like composing music, but for your mouth.
It boils down to two main principles, doesn't it? Complementary and contrasting pairs.
Complementary is when ingredients share flavor compounds, enhancing each other like mushroom and thyme. They just belong together.
Exactly. Or lemon and greens, tomato and basil. They have overlapping aroma profiles or taste components that just work harmoniously together.
And contrasting is all about balance. You have sweet and salty, rich and acidic, like a flavor seesaw.
Precisely. A maple glaze providing sweetness and salty umami. Sweet potato with a squeeze of lime, sweet and sour. Dark chocolate with raspberry, bitter and tart. Avocado toast with lemon, rich and acidic. Creamy hummus with crunchy vegetables, texture contrast. Spicy chili with cooling avocado, kinesthetic contrast. It's all about creating that dynamic interplay.
Yeah, and we can think of some brilliant examples based on these principles. Sweet potato and chili, mushroom and thyme, lemon and greens, tomato and basil, as you pointed out. Also beans and cumin, nuts and fruit, that's a classic. Dark chocolate and chili. Didn't know about that one myself, but that's what we found out. It's a good starting point for experimenting.
But you absolutely need balance, Chris. Don't let one flavour utterly dominate everything else. Be cautious with too much bitterness or sourness combined. And always consider ingredient quality. A watery, flavourless tomato simply won't pair the same way as a ripe, sun-kissed one. Quality matters.
And resources like cookbooks or online guides can be incredibly helpful here, like cheat sheets for flavor.
Hugely. Even if they mention meat or dairy, look at the plant-based pairings listed for a key ingredient, and you can often find brilliant vegan analogues. Nutritional yeast for cheesy umami, smoked paprika for smoky notes, mushrooms for that meaty depth.
It truly comes down to consciously building those layers of flavor in vegan cooking, using fats, umami sources, acids, of course, herbs, and spices, all thoughtfully and intentionally. It's an art and a science.
Precisely. You often need to deliberately add the depth and complexity that might come more easily from animal ingredients. Understanding the science behind it all truly empowers you to cook more creatively, more deliciously, and ultimately, more healthfully.
Okay, wow. That was quite the journey through the science of flavor. Let's wrap this up with some key takeaways. So, flavor is so much more than just taste. It's a magnificent multisensory experience. Vegan food possesses incredible flavor potential, deeply rooted in the chemistry of the plants.
And those very flavor compounds often perform double duty as powerful health-promoting molecules. Understanding all of this empowers you, our lovely listeners, to cook more creatively, more deliciously, and yes, more healthfully.
Absolutely. So, for everyone listening, here's something to perhaps ponder, a final thought to leave you with, a little homework maybe.
Think about a dish you absolutely adore, perhaps something wonderfully complex like a rich curry or a hearty soup. Try, just for a moment, to consciously identify the different sensory elements that contribute to your enjoyment. Where is the sweet, the sour, the salty, the bitter, the umami coming from? What about the aromas, the textures? Any of those fascinating chemical sensations like heat or coolness? And then, just consider how you might achieve a similar level of complexity and sheer satisfaction using only plant-based ingredients, drawing on everything we've discussed today.
That's a great challenge, Emma. It really makes you think about deconstructing flavor. Fantastic stuff.
Always a pleasure to dive deep into these fascinating topics with you, Chris.
Likewise, and a massive, massive thank you to everyone for joining us on the Chris and Emma Show.
We truly hope you found it as utterly fascinating as we did.
If you enjoyed it, please consider subscribing if you haven't already. That way you don't miss out on our next exploration into the weird and wonderful world of, well, whatever we decide to talk about next.
Thanks again, everyone. Stay curious and keep experimenting in the kitchen.
All right, that's it for us. Signing off, everybody. We wish you the very best. Until next time, take care.